Hi Year 10, this next video is on completing the square. So some quadratic equations we can't solve by factorisation, as I mentioned in the last video, as the solutions are irrational. So to be able to complete the square, we first need to be able to solve perfect square equations. And all that means is if we have something that's x squared equals k, then x could equal plus or minus the square root of k, and that is if k is greater than 0. X could equal 0, and that would only happen if k equals 0. And then if k is negative, so if k is less than 0, then there's no real solutions. So once again, this is looking at two solutions, one solution, no solutions. Okay, so for this example, we're just going to solve for x. So this process here is actually the last step of solving a quadratic by completing the square, but I'm just going to go through it first because it's the easiest part. So when we're solving these, just think back to when we did this before last term. We're going to get rid of the squared first. And so x minus 3 will equal plus or minus the square root of 16, which means we'll get x minus 3 equals a plus or minus of 4. Then we take the minus 3 over by adding it. So we'll have plus or minus 4 plus 3. Now this is where the two solutions come in. We've got the plus or minus 4. So our two solutions will be when x equals positive 4 plus 3, which is 7, or x could equal the minus 4 plus 3, which equals minus 1. And that's where the two solutions come in. So for part B, we've got x plus 2 all squared equals 11. So first step, take the squared over by the square root of 11. So it'll be x plus 2 equals a plus or minus of the square root of 11. Now we can't solve the square root of 11, so we're just going to leave it as it is. And then we are just going to take that positive 2 over, and it will become a negative. So we get the plus minus of the square root of 11 minus 2. Now that's our final answer there. We don't need to separate it. If you want to, you can. So you could write it as x equals the positive of square root of 11 minus 2, or x equals the negative of square root of 11 minus 2. But you don't need to do that step. You can leave it as that middle step if you would like. Now, forming a perfect square. So most quadratic equations, we're not given a nice perfect square form. And we have to go through the process of creating a perfect square, and that is what the completing the square process is about, is creating that perfect square. So to do this, step 1, we want to write the equation in the form x squared plus bx equals c. Second step, we're going to halve the b value and square it. So that value in front of the single x, we're going to halve that number and then we're going to square it. The number we get from that, we're going to add that to both sides of the equation, and then we can do our perfect square. So this example 2 is just about doing this process. We're not solving it, we're just going to create our perfect square. So first one, we've got x squared plus 8x equals negative 5. So first, write the equation in the form x squared plus bx equals c. It's already like that, which is good. Step 2, half the b value and square it. So our b value here is 8. So we want to half that, and then we're going to square it. But what I'm actually going to do is I'm just going to leave it as 4 squared, and you'll see why. So once I've done that, we're going to add it to both sides of the equation. So we're going to have x squared plus 8x, now we're going to have plus 4 squared equals minus 5 plus 4 squared. So that's step 3, add that to both sides of the equation. Now we've done that, what you'll actually find is the left-hand side is a perfect square. And all we have to do here is write it as a perfect square. So it's going to be x plus, now that number that we have there, the 4, is what goes in the brackets. Which is why I want you to leave it as 4 squared, so you put the right number in. And now the right-hand side, we're going to have minus 5 plus 16. So then we'll have x plus 4 all squared equals minus 5 plus 16, which is 11. And that's all I want you to do for now, because obviously the next step is to do what we did in example 1 and to solve it. So now we'll have a go at b. So excellent, step 1's already done for us. But step 2, we're going to halve the b value and square it. Now, we've got to take note that this is a minus 6. So when we're doing this step, we're going to have minus 6 divided by 2 squared, which will give us minus 3 squared. And that's what we're going to add to both sides. So we're going to have x squared minus 6x. Now we're going to add the minus 3 squared to both sides. Now from here, what we do is we're going to create our perfect squared. So once again, we're going to have x. Now whatever's in that bracket here is what goes into our perfect square. So it's going to be x minus 3 all squared equals 13 plus minus 3 squared, which will be plus 9. And so x minus 3 all squared equals 13 plus 9, which is 22. And that's that process. So now we can just kind of put example 1 and 2 together to then solve our quadratics. So in this one we're going to have x squared plus 2x minus 2. And our first step will be to rearrange it. So we're going to have x squared plus 2x equals 2. We're going to look at this b value here, which is plus 2, and we want to halve it and square it. So it's just going to be 1 squared. Now we're going to have x squared plus 2x, and we're going to add 1 squared to both sides. We can create our perfect square. So it's going to be x, whatever that number squared is. So it's a 1, so it's going to be plus 1 all squared equals 2 plus 1 squared, which is 3. And now we can solve it. So we can get rid of the squared, so it will be x plus 1 equals plus or minus the square root of 3. Then x equals plus or minus the square root of 3 minus 1. And there's your answer. And remember, if you want, you can write out the two solutions with the plus and the minus, but you don't need to. All right, B. Same idea. Rewrite it first. We're going to have x squared minus 5x equals minus 3. Now from here, we're going to look at the values. So we've got minus 5 as our b value. So we need to do minus 5 divided by 2 all squared. Rewrite our quadratic. So we're going to have x squared minus 5x. We're going to plus minus 5 on 2 all squared equals minus 3. And then once again plus minus 5 on 2 all squared. Create our perfect squared, which will be x. Now it's minus 5 on 2 in the bracket, so it's going to be x minus 5 on 2 all squared equals minus 3 plus minus 5 on 2 all squared, which gives us 13 on 4, or 3.25. And then we just solve it. So we're going to have x minus 5 on 2 equals a plus or minus the square root of 13 on 4. Now remember, with 13 on 4 here and the square root of that, we can rewrite that as plus or minus the square root of 13 over the square root of 4, which is 2. So we can simplify it that way. And then add 5 on 2. So we'll have x equals plus or minus the square root of 13 on 2 plus 5 on 2. And then we can leave it like that, or we can rewrite it as one fraction because now they're both on 2. So with plus or minus the square root of 13 plus 5 all on 2. We've got 2 more examples, just doing the exact same thing. So if we look at C, let's rewrite it. So x squared minus 4x equals negative 6. We're going to half the b value, so that's negative 4 divided by 2 and square it, which will give us negative 2 squared. Add that to both sides of the equation. Create the perfect square, so we're going to have x minus 2 all squared equals minus 6 plus minus 2 squared, which will give us negative 2. So it's going to be minus 6 plus 4. Now we can rearrange this. So we'll have x minus 2 equals plus or minus the square root of negative 2. Now from here, we just need to stop there because we have the square root of a negative number and it's not possible. it means there are no real solutions. Because it's a negative underneath the square root, we can't solve that, so you have to remember that's a no real solution answer. And D, last one. Now with D, our issue here is we have a 3 in front of the x squared and we can't have that. So our first step here is going to divide everything by 3. Because that will get rid of the 3 in front of the x squared. So we'll end up with x squared plus 2x minus 2 on 3 equals 0. And now we can do our process. So we're going to have x squared plus 2x equals 2/3. Take the b value, which is 2, halve it and square it, so we're still going to get 1 squared. So we'll have x squared plus 2x plus 1 squared equals 2/3 plus 1 squared. Create our perfect square, so we'll have x plus 1 all squared equals 2/3 plus 1, which will be 5/3. Now once we've got to this step, what you will see is that this second part here, the square root of 5/3, can be written as the square root of 5 over the square root of 3. Now remember, we don't like surds on the denominator, so we want to rationalise that. So to do that, we times it by the square root of 3 over the square root of 3, which means we'll get square root of 5 times the square root of 3, which is the square root of 15, and the square root of 3 times the square root of 3 is just 3. And then we can take that 1 over. So it'll be x equals the plus or minus of square root of 15 on 3 minus 1. And if you want to write that as a single fraction, you can do, which will be the plus or minus the square root of 15 minus 3/3. That's not necessary, it's just another way of writing it if you wish. And that's completing the square.